All right, we are live. All right, I just wanted to actually start the stream instead of having it take a couple more minutes for it to go fully live, but I'm not fully set up, so bear with me here while I actually finish that whole process. I need one of those like stream starting soon screens, so it's like the stream is live, but like I'm not actually live yet. You know? Have some like cool music going. That would be what I need in this exact moment. But we'll see how fast I can speed run everything else needed. I'm like, go. Yes, do not need new quest boundary. Alright, and bring up the desktop. Throw on, where's my headphones? Where did those go? Ah, they fell. And let's get some music going as well. That way I can test to make sure my audio, not my mic, but my audio is actually working. We'll go with that for now. Is my audio set correctly? Is the question. Okay, it looks like we only have one mic, one desktop audio. Alright. Good on that front. Where? Ah, my controllers are across the room. Dang it! The thing about my current desk setup is like I construct it around me, and then if I have to get up, I like have to deconstruct it. It's inconvenient. Alright. Okay, let's get a VRC instance up. There we go. That works. There we go. Let me change mic so that mouth actually moves. Let's see, Steam. I guess that would be Steam streaming microphone. It is. Oh. Here we go. Alright, yeah, that's how long it takes for me to set up everything. To actually be ready to start streaming. Let me bring up chat again. Hello! How's it going, everybody? YouTube chat is up. Let me make sure I have... Let's see if we even have, like, Twitch working right now, because it like occasionally works, sometimes doesn't. All right, there we go. Stream is set up and going. I kind of resize this window so it makes more sense as a stream cam. That's roughly about webcam shaped. Yeah. Okay, alright, what? It has been a while since I've done a stream. Like, like 2 weeks or something like that? So, what have I gotten done in that time? Well, I'll tell you, not very much on the game engine, that's for sure. Not very much on the game engine at all. However, I have gotten a lot done in other areas. Let me see if I can, in like my browser, bring up what I actually have been up to. Because what I have been up to was actually pretty exciting. Ah, yes, look at this. The VR Chat Space Jam. And if we look... Oh, if you look closer... Who's that? In the number 2 spot. Alongside some really cool people. Yeah, what I've been doing for like the last 2 weeks was... I went over to Thrill and Fia's place and worked in person on a world for the VRC Space Jam, and we got 2nd place, which is pretty cool. It was a really fun experience. Little stressful. We were working really hard, but it was a really fun experience as well. But yeah, so like last weekend I took people on a tour of this. But if you're interested in seeing the world that we made, now that all the bugs are patched, well, most of them. There's still like a couple late joiner bugs, but let's see. The world we made was this one, the Be Sustainable Company, or BSUS for short. Yeah, we have like, I mean the CCU has gone down a little bit, but it's at like 26,000 visits, which is pretty crazy. That's significantly more, that's like twice the amount of visits as views like my best YouTube video has ever gotten. So that was a cool experience. But now I need to get back to work for a little bit. Before I get sucked into another hackathon, because the meta hackathon for Horizon Worlds, we're also considering doing an entry in that, and that would be like about a month away, like 3 weeks away. So we'll see if we actually do that, but we're gonna see if we can get some game engine and scripting language done before that. Yeah. What is your opinion on the Gex trilogy releasing on stream? I have no knowledge of this trilogy, therefore I have no opinion. But yeah, so I've, over the last couple days, been thinking about what I need to do next on the scripting language. And the thing that I'm like most concerned about now is making sure we have a good architecture for the actual compiler. Because before we go any further, so there's this thing I need, like, I keep using confusing terms for this thing, but in reality it's actually L value. Those are the C++ terms for this concept, L value versus R value. Basically, behind the scenes, when you're looking at your code, the compiler is storing potentially 2 values for every single variable in your code. So let me find like a let statement somewhere. Or even better, let's find a borrow somewhere. Or a reference, so I can illustrate my point. I need somewhere where I make a local I'll just like write something out here. So let's say you have, I can int my var equals some value, and then you do your variable reference is a reference to my var, but in here you also have, or my var2 is equal to my var. Oh. So what's going on here? What is hard about this in my mind for making compilers? Well, it's that both of these want different information. So the my var label refers to both the memory address of my variable. So 22 is stored at a memory location somewhere. So right here, I'm not referencing the memory address. I'm referencing the actual value stored at that memory address, and it's like implicitly fetched. So behind the scenes, when you're actually writing like the SSA form, the intermediate representation, you have to explicitly say, in this situation, I'm using that memory address of this variable, and over here, I'm using the value at that variable. So there's an implicit dereference that happens here. Now, what if I, like, on the right side of this expression, just put a function in there, and never explicitly store the result of that function in a variable? That result never has a memory address that it refers to. So of course the ampersand, is this an ampersand? Yeah, ampersand, that is like the address of operator, that won't work because there's no address to be able to fetch. So there's kind of like this, alright, so I need to implicitly dereference, or on the compiler side, I need to store all values that have memory addresses as their memory addresses, and then implicitly dereference them, and so that if I do an operation that requires a memory address instead of a value, I have that memory address to work with. Whereas in the instance of like just getting a value, Anyway, these complexities are just to do with the architecture I have now of L values versus R values. So the actual like terminology for all of this, now that I've explained like kind of the way that I was thinking about it in my compiler now, and the thing is, like, I've already solved this problem in the past in the way that I currently do, but never in like the way that I want to refactor it to work. Which is the C++ terms for these concepts are L value versus R value values. So left values are things that would be on the left side of this equals statement here, on the left side of an assignment. So L values are values with memory locations, and R values are values on the right side of an equation, or that only have a value that could be stored only in registers and not actually have an actual memory location. And the way that I was handling all this is I had a boolean called isDref. In past systems I've written, it's called I call it like isTemporary. And it was kind of like whenever I did an operation that required a like an actual value, and I passed in an R value, I would just put an automatic dereference. But that's like, there's a lot of mental and like design, well, not design overhead, but like it's just a hard thing to program around, the idea that every single value could either be a memory address that we need to dereference or an actual value we can immediately do operations on. So I wanted to figure out like a cleaner way to handle all of that. Either make the implicit dereferences explicit, or just come up with a like cleaner way to handle all of that. And I think the cleaner way I'm going to handle that is, which file am I in right now? I believe I'm in the compiler. Yes. The way that I'm going to handle this is by structuring the way that I compile things differently. So right now, the way that I write out my intermediate representation is by taking my document context nodes, which are essentially another AST. I transform from the tree sitter AST to document context nodes, which are essentially a secondary AST. And then I transform that directly into like mid-level IR. Like, let's see, we need 2 IR pass? 2 IR? Yeah, there it is. Generate IR pass. So I have this generate IR pass, compiler pass, and it's essentially just a bunch of recursive functions. And the way that I've handled this in past compiler systems in C++ instead of Rust is, instead of recursive functions, instead it's recursive calls through member functions instead of on one object doing recursive calls on itself. So what I think I'm going to do is, instead of this being instead of doing this through recursive calls on one object, implement traits on the document context nodes and have recursively calling. Oh, I don't have my hand gesture locomotion gestures locked. I feel like I just jumped there. Okay, let's just lock this right there. Oh, did I recenter? I think I recentered. There we go. That's what went on. So let's lock those controls so I don't accidentally do that again. There we go. But, yeah. Basically, I'm just going to restructure how compilation works. Not necessarily change the substance of it. But then, what I'll be able to do is have a... I'm probably going to use the terminology from Rust. So instead of L value and R value, it's going to be value a value and place expression. Or, yeah, on each expression I can call place and value. And the place will return the address of an expression, or like try place or whatever. And we're also going to refactor parsed documents to instead be a high-level intermediate representation instead of a direct clone of the AST. Because I think I can get... Because my idea with document context is when I eventually write a... language server protocol backend for Brane script, I was thinking, document context. That's my version of an AST that's easy to like parse over and do queries on. Yeah, but in the end, it's like now we just have two versions of an AST, and we do actually need something lower level than an AST, but still higher level than a intermediate mode, or not intermediate mode, IR, like low level IR, or the IR that we're actually serializing, before we get to all the way down to, yeah, we need an intermediate representation, like a high level intermediate representation, before we get to the mid level intermediate representation, if that makes sense. And that is an idea I got by actually looking at the source code of the Rust compiler, because I was like, how did they handle this? And the answer is one more data structure. You just need one more data structure. You're just like, okay, here's the code, and then that code gets turned into an AST, which represents the exact same thing. And then it gets turned into high-level IR, which represents the exact same thing. And then it gets turned into mid-level IR, which represents the exact same thing. And then it gets turned into LLVM IR, which represents the exact same thing. But each one is slightly more lower level, slightly more optimized, has more information. Just iteratively going from first draft to final draft. Yeah, and one of... Here, let me go back to my Notion document, because I might need to throw more stuff into the In Progress tab. And I'm going to throw Manage Desugaring, and I don't think I'm going to implement automatic type resolution just yet. But, yeah, one of the things we're going to do here is... instead of representing operators as operators in our high-level IR, instead we're going to do... Now, Rust keeps operators in their high-level IR, but I'm going to kind of jump the gun a little bit, and in our high-level IR, there is going to be no representation for operators. Instead, operators, when translating... Oh, I'll just do here. Translating from AST to HIR, high-level IR. When translating from AST to high-level IR, what we want to do is convert all operators to trait function calls. So right from the beginning here, now after this, we're going to have to actually implement intrinsic functions, and I guess that's one thing we need to do is add support for intrinsic functions, and this is a Brane script thing. So we're going to convert all of our operators to trait function calls. So that means by default we have operator overloading, because if you implement the trait for that type, like if you implement the add trait for a type, it now works with the add operator, if that makes sense. So we're just directly stealing that from Rust, because I really like it. It's super clean. Everything just kind of works with the same system. And this is actually how it worked with BraneScript 1.0, and I don't know why I haven't implemented it this way yet. I think I was rushing to get something that was working, and I was intending to do this eventually, I just hadn't done it yet. So we're going to convert all operators to trait function calls, and then in our HIR, we won't have a representation for operators. Literally just function calls. And then when we're translating back to mid-level intermediate representation, so here when translating from HIR to mid-level and intermediate representation, so mid-level intermediate representation is, or just regular IR, that's when we want to translate from function calls back to native stuff. So to-do list, when translating from HIR to mid-level IR or regular IR, we want to convert intrinsic functions to native operators, operands, like so. So this will either be we'll implement a closure for every single intrinsic function, or we'll come up with some sort of method for like pattern matching. Function operands to native operands. It's probably gonna at first just be like a closure, where I get the arguments of the function put into that closure, and then we make them be operands to native operators instead of yeah. So where do we start with this? Because this is a lot to take on. We definitely don't start out with implementing intrinsic functions. Well, actually, there's two parts of this. When translating from the AST to HIR, we need to convert operators to trait function calls, or desugar them. And that is part of, well, that isn't part of intrinsic functions. That is part of desugaring, which is this. So we have that there, and then part of this, how we're going to do this is or convert document context to HIR, and sub versions of this is remove all operators remove all operator expressions. And that's like my main thing right now. After that, we need to implement convert or change HIR to version to use recursive trait calls instead of compiler passes is what I'm going to call that. So, looking at everything, this is kind of like a sub thing we do at the same time as, yeah, desugaring is a subtask of this whole process. Like, these are all intertwined. Like, all of these need to happen to work together. They're like one thing, I guess. And the first thing we need to do is essentially go over all of, you can see right now we're in the HIR file. So if I actually split files here and go to this document context, you see they're the exact same file. If you look at the bottom of the page here, you see this one's document context and this one's HIR. Because I just copied this one, and then we're going to change that one to represent the fact that it is high-level IR. Come on, let me close it. There we go. To represent that this is high-level intermediate representation instead of, yeah. So I'm going to change the names of everything. We're just going to do a pass over this file and change the names of everything to represent the fact that it's not an AST, it's a high-level intermediate representation. And then we're going to go over the parser and rewrite everything there to also match the fact that it's AST to HIR instead. So we might actually move parts of the parser into the HIR folder. But yeah, so instead of text source, I want this to be more generic because we might also have node sources. Then again, no, nodes are compiled from text. Nodes implement. So this can still be text source, but I'm going to just rename this to source This is going to be, instead of text context, this is going to be a see, the way that the Rust compiler does it is they have it as a slice. Hello, welcome to the stream. This, I kind of also want to call this text source, or I guess this is explicitly a text source. At some point, if we do have multiple sources, which I'm not actually planning on, we'd make this a trait instead. Okay, and that is like range. No, this is typesetter range. I'm not sure if I want this to be a typesetter range, because I realized that for macros to work in the way that I want them to, we're eventually going to have to rip out tree sitter and potentially write our own parser and lexer and tokenizer, or use a different one. I might use the same one that Rust Analyzer uses to create an AST, because I think there's a chance you can get the raw token stream for that. I would have to check, but I think there's a chance you can get the raw token stream for that. Or you need to provide it with a raw token stream, in which case, yeah, now I would still need to write a tokenizer for that. Oh, right. But yeah, so we have source of the file, because in one module can be built of multiple files. That's one thing we do differently from most languages. So we have a source, then text, I'm gonna call it node source, and then our range is going to be, see, I do like the tree sitter range with start end by start point being a row and column. I do really like it being a row and column and not having to retroactively manage stuff like that, or change stuff. There's stuff like this is going to be like parsing over stuff like super often, but we can optimize that later. I think for now I'm going to change range to be not type sitter range, but instead a standard OS or standard operator range. So instead, yeah, this is just going to be a regular, what? Oh. Regular range. We do need to give it a type, which use size works for now. And now all of these node sources are suddenly invalid. Identifier, we do want to work the same, I think. Script identifier, yes. So I'm just gonna say, text source with node source. we implement display for these, which is fine. I might want to move these implementations out to a different file at some point. I'll keep type modifier, I'll keep most of this the same. I do want to no longer do context for everything. I wonder why project context. Maybe it's because I didn't do /global. Oh, we're not even moving files. We're like completely refactoring them. Expression const value. Come on, const value should have an implementation of context. Oh wait, it is an enum. Oh, it's because const value and const value context are two different things. Right. Do I add in a context to these, or... How do I handle this? I could put mini structs or inline struct definitions in here. Like value. Also. Kind of like that. And then I would need to implement I need to do the same thing for unary operator. Oh, wait! I don't need to do the same thing for unary operator. I can just delete it because it's a function call now. And binary operator just gets nuked. See, a const value, I do need to make an implementation to be able to grab the context out of it. I'll just do that real quickly. And I will say, I really love that in Rust you can make function calls for enums. Like, it's amazing. thing is, do I want this to be context or source? I think I do want this to be source. Alright, and source is going to return a node source. And yeah, match. Do you want to do a reference to node source? I think I do want to do a reference to node source. It does have clone, right? Yeah. There's more Vim ways to do this. Oh, do I have to explicitly fully unpack that? I guess. What? Was I being lied to? Oh, you have to rename it. Like that. Can see my too much time in C# or udon slipping through when you start putting parentheses, not parentheses, no, they are parentheses, I think. I'm forgetting the names of things. Coding it too much in udon recently has nuked my brain. I'm gonna blame udon. Udon is a good thing to blame for everything. Naming, syntax, and off by one errors. Indeed. And also null pointer error. Much null pointer, undefined object, or not undefined object, null objects in C#. It's like, I thought I remembered to set that reference. Oh, the two most. Right, yeah. Sorry, I forgot. I've heard the joke before, so I was like, ah yes, coding joke. Funny, I have heard before though. But I forgot the actual joke. Though technically, if you did while less than 2, no, actually that still would be an off by one error. Alright, and Rust had a name for, this is like a field. I want to yoink Rust's name for member access nodes, and I want to see what their labeled value reference nodes are called as well. See, you don't have to come up with names if you just steal them. Depends on if you start at 1 or 0. Well, if you start at 1 and do a while less than 2, then you're gonna have a off by 2 error. Call node. The only node that I'm gonna have to use from this point on is so beautiful. No operator stuff to deal with. Dang, I also have to add in module linking as part of explicit functions or intrinsic functions. I'm also going to have to add in traits and trait implementations. Oh, is it because they were both named source? It was. I completely missed that. But yeah, now source is inside of the text context of the document. Just has a list of node sources. Double the source, double the power. True. Double the debugging time. Or double the source, double the fall. Phone buzz. Why phone buzz? Discord notification. Eh? Alright, I will respond to that after stream. Alright, and I'm gonna hide that so it doesn't distract me. Alright, letting my brain restart us after a second. There you go. Okay, and that's just the creating a project from a bunch of documents. And then we don't need a unary or binary operator. Yee. Well, the plan was always to add traits. You gonna have a trait solver? Explain what a trait solver is. Generics? I will have generics at some point. I am a big believer in generics and macros. We'll see when I actually like get around to fully implementing those. Ooh, fun side effect of the way that modules work in Brane script is if I do get around to making proc macros and whatnot, have something like trait A plus trait B and then T something. Maybe. We'll see. I'm not sure on that one yet. I'm just kind of adding features in one by one as I need them. Oh yeah, right. Back to like the proc macro thing. One of the side effects of how I'm organizing, like how it compiles stuff, is every single module with the same name is compiled into the same compile target or same module. So unlike Rust, where you need to have separate files, separate crates for doing procedural macros, with mine, you could put procedural macros in the same file as your other code, because there's already a compile step where we load every single document and then sort their contents by module. So you just need to have the proc macros in a different module, and then it's in a different compile target. So instead of ref, this is going to be node. E. Then another thing I'll probably need to add in here is some way to do like a use statement, a way to link modules to other modules. Maybe that's just part of modules or part of, yeah, I don't know. Music ran out. What if I just played the Vertigo 2 soundtrack? It's always a temptation. Alright, we have music again. So how are we going to handle imports? or imported functions. Because we need to, at some point I'm going to need to represent the, this trait, or not this trait. This module needs to link to this module before actually sending it through compilation. So how in our intermediate representation, or does our high-level intermediate representation even represent that? I guess at which stage does that get resolved? Which stage at... Because there's multiple stages here. There's so we get it as an AST from TreeSitter. Currently that's getting turned into document context, which we are currently in the process of refactoring to high resolution or high level intermediate representation that gets turned into IR, which then gets to can I type? Yes. So this could theoretically be serialized and sent over the network, and then we turn this into LLVM IR. And then here's the thing. This right here, function links, are needed here at the LLVM IR stage. But we want to check them before the serialization stage. So might make sense to either here resolve not function imports, module imports. Might make sense to do when we transform from the AST to a high level IR. But the thing is, if we're in the process of parsing the AST, that means we don't have access to everything. Like, we don't have knowledge of every single document. So if we tried to resolve module imports here, then we would get failures. So we could store I'll just say module imports, and then when this gets transformed from, well, here's the thing, I want to do several passes on the HIR to fully resolve things, so there's going to be several HIR passes over that. So we need to store module imports here, and since module imports are, since the way our pipeline works is a project compiles any form of Scratchpad. If I had like an easy way to like write, I would actually be writing on like a whiteboard or something. Maybe when I'm eventually building stuff inside of the engine itself. Which is a thing that I do plan to do eventually, several years in the future. Have like an in-game like marker board I can write on. Would be super sick. Not that, you know, like, I couldn't just put a marker board in this world and use that, but I'm, like, kind of stuck in my chair. For the moment. Oh dang, now I want to make a project planning tool that works from within a VR world. Because like I have this whole like project planning system that is essentially like imagine a Trello board, but it's nodes. And you can like, if you do sub to-do steps on stuff, you would see that displayed on the node, and you could see like a progress bar across all the nodes. Like that's something I very much want to build at some point. And I just realized how cool that would be to have in VR. So I very much might make that at some point and use it in the project as the main planning system. Right, back to what I was saying. So imports need to be stored at the module level, since the module level is the level at which imports occur, and documents, which are our text files. We can't do like use statements or import statements at the document level. You can let the programmer do it, but they need to be resolved yeah, those need to be resolved at the module level. So module here. So we'll say pub use. And this isn't even really a hash map. This is a is this something where I'd have to, like, do that? Yeah. So here's the way I'm gonna handle this is... a use tree is, well, I don't think I actually want to represent this as a tree. I think I want to use identifiers. Oh, see, here's the thing where use statements are a grammar construct. Like, they're part of the grammar of a file. So for modules, pub I'm gonna call this links, and I need a scoped identifier. Oh, is scoped identifier even... we'll do vector for now, since we don't necessarily need to do lookups on that. So this is going to be the full address of every single module that we use functions from. And I don't think this needs to be populated when we generate the HIR, and I think it's one of the passes of the HIR to actually generate that. I don't know, this could be a grammar thing too. Yeah, okay, I'm gonna revise this. So I'm gonna new line this so we can actually like so when we do this conversion, expand scoped IDs, and then we're going to have an HIR pass to verify links. But we're going to expand the scoped IDs we're going to expand the scoped IDs when we translate the AST explicitly. That way we don't have to do any form of lookup logic whatsoever on every other part of the pipeline. Is just there is a full path to every single construct that we're working with, and we'll verify that those constructs exist before moving on in the process. So yes, we will just assume that everything has a fully like scoped identifier. So real quickly, I'm going to double check where is it? So it's in Rust _ HIR. Here. Then where is expression? We need expression kind. Because I want to steal their naming conventions, because my names for stuff are uninspired. Well, overcomplicated. They're multiple words. Well, I guess this would give me every single form of expression. Aha! Here we go. So you have call. What is the difference between call and method call? First field resolves into the function itself, usually an expression kind path. And the second field is the list of arguments. This is the thing. Maybe instead of scoped identifier, I just call this a path. I like that idea. And this won't be confused with anything else ever, and it's fine. So this gets expanded out to a path, and then these are the arguments. A method call such as... Okay, so method calls are calls with a self argument. My question is, why are self calls different? Because, like, you can, well, here, I'll kind of write this out, my, like, thought of why this is a little bit confusing is because, let's say you have a type A. I'm going to use C# syntax here because this is pseudocode. And if we say a dot foo, here's our method. Now, behind the scenes, we can represent this as type, and then foo, and then pass in a. And both of these could be valid ways to call this function. In fact, in Rust, it lets you do both. So, why are there separate constructs for a method call? Because, like, if foo is defined as function foo, and then it has a self argument, and this the type of this self argument is type, then, like, there's no difference between this and this from, like, an actual structure of the language standpoint. So I'm wondering, what is type dependent def? The path segment represents the method name and its generic arguments within angle brackets. The reference expression is the expression that evaluates to the object on which this method is being called on, and the expression, or slice, is the rest of the arguments. Thus x.foo, and then expression kind, method call, path segment, it's still a path segment, and the self value is... See, I don't understand why this needs to be a separate language concept or a separate part of the IR. Unless, well, I guess this level of the Rust IR still has, like, binary and unary operators and index operators and whatnot. So their high-level intermediate representation is higher level than the intermediate representation that I'm doing. So maybe this is just like they're trying to keep more of the language concepts than I am. It's like, here's a using statement, and I'm going to try to get rid of using statements and reduce them down to what they are. Well, not what they are, but yeah. I guess if I'm doing validation on using statements, for me to properly return errors to do with using statements, like, let's say a type doesn't exist in a certain module, and you try to make a using statement that says, use this structure from this module. You'd want the error to show up on the using statement, not on the first use of that used structure. And if I completely abstracted using statements out, then errors would be nonsensical. Because, like, you'd say use struct from module, and then you would actually reference the structure somewhere in your code, and the error would show up on the structure in your code and not on the actual using statement saying, structure such and such doesn't actually exist in module such and such. And the using statement wouldn't have an error on it. So you do kind of need to represent the using statement somewhere. If for no other reason, then it needs to be validated. What is a become expression? Oh wait, Rust has coroutine support? That's cool. Well, I guess async would be a form of coroutine. Well, async is purely coroutines. Async is coroutines that happen on multiple threads. Okay, so if I use this approach of AST, and when we're parsing the AST is when we expand out all the scoped IDs. Indeed, we like multi-threading when it works. That's the point of, like, half the point of Brane script is easy multi-threading. We'll see if it actually works out that way. Every pipeline is actually an abstraction of a multi-threaded coroutine. So all of Brane Engine and Brane script using things will be multi-threaded by default, which means I'll basically be using Brane script to code everything that I want to be performant after I get a UI library in there. Pipeline-based UI is going to be a very interesting thing to develop. Okay, so if I expand out all the scoped IDs here, and then don't represent using statements in the high-level intermediate representation, that means when we then verify the links, errors are going to be in the wrong place and not very usable. which means one of a couple things. Either I need to make the high-level intermediate representation higher, and don't expand scoped IDs until a pass during this. We need to like verify links before we expand scoped IDs. And then we need to verify links again after expanding scoped IDs. That, or I add a little bit of spice. Here's what I can do, is whenever we have a scoped identifier, or a path, hello, we are working on a scripting language for game engine. So we have this path with this set of node sources, but what if we were able to make paths this is so cursed, but it kind of makes sense. So hear me out. When we're parsing paths, we have the option, as long as it makes a usable amount of sense. Yeah. So to not have to do like our link verification multiple times, what we can do is actually expand scoped IDs. Well, we don't expand scoped IDs. Instead, we parent scoped IDs to using statements. So if a path, not scoped IDs, come on, give me my, where are my Vim keybinds? Am I hitting like, oh, there it is. We want to rename scope segment to path seg. Man, that lagged out a ton. But yeah, now we have path segments, and these segments are made up of identifiers or traits. Or turbofish things. But yeah, so if we have a parent path, and then scopes from that parent path. So the way that path parenting will work is if we have a use let's use traits, for example. Use standard ops add, or let's do let's do collections hash map, for instance. Then in our document somewhere we have a pub struct thing, and this thing inside of it has a pub map hash map. This here is stored as a path, or a scoped identifier as I like calling them, but we're calling it path since that's much simpler. We have this path here, and inside of our AST, or when we're parsing, we'll just throw this path here into an arc. So will contain one of these. So parent is going to be this, and then see there's two cases. Either we'll have hash map, or we'll have map, and then let's say get. I don't know if that's an actual thing, but then get map get gets resolved into hash map get. Or actually this, I don't know if I auto resolve this into its full path or not, but this could get resolved into a parent is that whole thing, and then segments contains just get. So the majority of the path information is stored in that shared path from the using statement, and we just kind of truncate this to just be one extra segment longer than that. Yeah. This is a little bit complicated, but I think it makes sense. Oh dang, do I have to turn on lights? I think I do, because it's starting to get darker outside. Do I have space to plug this in? Yeah. Yes? No? What is that plugged into? Is this plugged into anything actually important? Oh, that's my camera cord. My camera that is not currently plugged in. Not my router. I was worried that that was my router cord. Okay. Stream is still up and live, right? Oh, is my Twitch stream down? Okay, no. The internet is still fine, so I didn't just unplug my router. And I'm gonna throw this light over here to the side so hand tracking still works. Okay. The sun is no longer abandoning us. We have our own sun. So this is how I'm going to solve both errors. Yeah, this is how I'm going to solve errors, because I mean, now every reference to a thing is going to spam errors. I think that's fine. We potentially can collect hashes of like similar errors and collapse them so we don't get like spam errors. But that's a different problem. Spam errors are fine. Man, and that means like using statement stuff like this could be like, ah yes, this standard is a parent of this path, and this path, and this path, and then this path, and then every reference to arc is parented to that. Because this is technically that. But I think that does solve our problem. So paths now have parents. Now, do I have to implement traits here? I think I do need to implement traits here. Because my whole, like, operators thing is... So I need to implement both traits and member functions for things, or implementations. So this is an implementation for, we're gonna say for type. Yeah, we're gonna say trait is actually, both of these are a path. And implementations can be for either for traits or just for member functions of the type themselves. And I want to use the same implementation structure for both of those. I guess, actually, what does Rust do? Since I'm blatantly ripping off Rust for so much. So where is node? So there's expression. What am I looking at? Trait. So there's trait reference. References, traits, and implementations. Oh, interesting. So what was the... Oh, we'll just look up trait. Function signature, trait item, represents an item declaration within a trait declaration. possibly including default implementation. A trait item is either required or provided. Oh, interesting. So trait function is its own type of function. Ooh, trait item kind. So these are the items that are in a trait. So is this used anywhere? So there's the full trait item. Is this used anywhere? Or in the greater document, are there trait items within a trait declaration? So what is an owner node? Hey guys, what's up, Var? Trait item, implementation item. Trait reference. I would think that these are in... that these would be slightly more scoped than just trait and implementation item. Oh well, I'm gonna do this my own way, which may have good consequences, it may have bad consequences. Alright, so this trait has this identifier, and then, I'm gonna have functions. This is gonna be a vector of call sig. We only need the call signature. Now, do I also need to implement generics? I at least need to implement generics for a self type. Or maybe I can just have that be like a magic type, like a self type. Yeah, I think implementation if we're implementing it for our current type, self gets expanded out into, yeah, so the trait doesn't actually need to worry about that. It's just the trait expects these functions, which is fine. Well, I guess... Man, this is using enums even more than I am. Well, a lot more than I am. So if I could go to implementation item, it's like implementation item kind, and the kind actually stores the data. I don't like kinds storing data. Because for me, like, kind is an indication of the kind, and then the actual value is stored elsewhere, and the fact that it's an enum implies that it is a kind. If it was a type and you just called it type, I guess, well, no, the variable would still need to be like variable or something for me to be happy with that. So members of a trait can either be a function, they can be a type, or a constant. And now, do I give them... I find hash set in the scope. Oh, map. Do I give them default values? At this stage, I don't need to give them default values, but I'm tempted to just put it in there as like a... You know, there's an option default value. Wait a second. So for function, it's a call sig. It's just a call sig. Technically, this could be either a call sig or a full function if we want to give it a default, like, generic implementation. You know, I'm just not going to worry about do I want to give the constant a type? Yeah, it needs to have a type, and so that's the type of the constant, and then this is the identifier of the constant. Yeah. So technically this is a generic constant, this is a generic type. When I fully implement generics, I'll refactor that. Do I have adding generics to the list of tasks? I do. It's right there. Actually, I'm going to keep that open just to fill that screen space. So I think this is all I need for now, is we now have trait members, functions, call, which are just a call sig, because we're saying they need to make this function. We have types. Which can be used in the call sig. And technically, traits themselves can also be generic. Oh, do I need to implement generics right now? I might need to implement generics right now for all of this to work, too. Okay, if I do standard ops add, because like the add trait yeah, it was a growl, like ah. Okay, so there are many levels to this. Because they're saying the already existing self-generic right-hand side. So they are using a generic for the right-hand side. So the right-hand side of this is by default the same type. And then there's also an output type, which is a generic. Well, not generic. This could work using the current system I was writing. And then this function is expected to output that output type. So we add self with whatever the right-hand side type is. And then we return whatever the output type is. So there are a ton of different language features here, which I was like, I'm gonna have that, but without the to-do. So thinking about it, I don't think I need to do this as a generic. Simply because the syntax for writing identifiers is implement trait for type. Then that sets the self and uppercase self generics. Because I could say self is of type self like that. And this means exactly the same thing. That was like a sugar for this. Syntax sugar for this. And then we can just have self generics magically work. That's pretty easy to do. Self is just replaced with identifier. And then I could just have, in my trait definition, also have self. So if we're doing an implementation of add, it would just have to be add as always with yourself until we implement generics. And then when we have generics implemented, then the add will also be able to be overridden to work with non-self types. Do I have casting? I do have type casting. So, all of that to say to myself, I don't need to implement generics yet to get traits working. I do wonder, what is our path syntax going to look like? Because there's the turbofish syntax. So if you have module, 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 trait, and then turbofish type, or I guess path, and this is the type the trait is implemented for. If we have a generic, do we just do another path? Or generic args? Or do the generic args come... So it's this trait with these generic args implemented for that type. Honestly, it doesn't really matter because it gets resolved to the same point. Like, we're already at this trait. Or do I do generic args and then trait? No, for the purposes of lookup, this makes more sense. What would a full Rust path with What would a full Rust path with turbofish syntax look like for a generic trait? Or for a trait with generics? So my type as trait. Oh, so is this what the type as trait syntax is for? Thing is, I was writing a parser for REST paths before, but those were function paths. Which I still need. This would still be part of a function path. So the method's generic params. Concrete type as path to trait. Is that the syntax? Type as the path to the trait? So I guess this is just how you refer to a trait. That is the path. I thought this turbofish syntax, or the syntax for a trait, was module trait. But apparently it's the start of the path is the type that the type is implemented for as that trait, and then if that trait has generic args, you would do that. Between multiple traits that define a method with the same name, you're associating and not using operator sugar. Oh yeah. Fully qualified syntax. Well, alright then. That definitely clears up my confusion. I'm not a huge fan of the syntax, but it does clear up my confusion. The syntax could grow on me. But that does mean for path, our paths to be able to support that, we have path segments where we have identifiers. But we all, wait, headset battery's low. It hasn't been plugged in this whole time. Dang it. It's fine. I have a cord that definitely works. Okay, we're good. Headset isn't going to die now. There we go. Took me far too long to figure out how to recenter. Okay. So identifier. We're gonna say trait. We're gonna have the path to the trait and the path to the type. And then I guess generic args is also one. Which we'll just have that there as a placeholder. But the distinction of the trait, for referencing a trait, you do need to reference the type and the path. That makes sense. So now we, yeah. I guess that would only be at the base of a path, maybe? Yeah, that would only make sense at the base of a path. So in my mind it would be path to trait, and then the type that the trait is implemented for as a generic argument. Because this isn't a very searchable construct. So I'm gonna say generic args. And just say generics. This is going to be a vec of generic arg. And this can be a path. What else can this be? This can also be a constant, which if I go back to wherever trait is, yeah, trait member here. Yeah, so we'll allow const value here. Technically there can be, if we're going the Rust route, there can be named generic args. But do we need those yet? Not at the moment. So we have types here. We have constant values here. Do we want to let them be nameable? Not at this point. So yeah, now we need to Right. Can I have muscle memory, please? There we go. I think that solves the problem. So now, oh, nope. Constant value does not implement display. I wish pasting. Here we go. Nice. No valid diagnostics. There's our valid diagnostics. Code actions didn't pop up until I was already done with the thing. That is pretty funny. Does it go away now? Or do I have this window open forever? I think I have this window open forever. 1 second, we're gonna write all workspace save, and then okay. Trying to quit. It was like, you haven't saved the buffer that is the input to this field. Let us take you there. And I was actually able to close that. Nice. We're just gonna restart just to be sure. So I think paths are fully implemented to the point where they will eventually be able to support generics. They will be able to support they will be able to support Brane. Work with me here. Traits. Though I haven't fully decided on my trait syntax, because I don't like this syntax. This isn't a very searchable syntax. I feel like trait, then the type, and then generic arguments, maybe? Okay, I think the way that I want paths to traits to work is path to trait, type trait, That's an interesting thing, though. How do I handle trait implementations and finding those? Where are trait implementations stored? Because are they stored on the actual type, or are they stored on the trait? Because could it be path to type, path to trait, and then trait member? Because it's really just an implementation detail of where do I store this in the compiler. Okay. I like the idea of it being path to type, and then path to the trait, and then the trait member. Though, here's the thing. How do I handle the case of module 1 Module 1 defines a structured type. Module 2 defines a defines an implementation of trait for type. And in this example, the trait location doesn't matter. Traits themselves only exist in the source code. Trait implementations exist in a module. And what we need is a way to match modules and their members to code in other modules. So module 3, we have function foo, and in here we do trait method, and this module now needs to link to this module and okay, let's say the trait is also defined on this module. So both the information of the struct and the information of the trait are in this module, but the implementation is in this module, and I do want to allow that. This module here needs to link not to this module for the type or the trait, but to this module, because the functionality for that method is in here. Which means this code here, we need a good way for the compiler to go. Alright, we have this implementation of this trait inside of this module, this compile target. Because modules are analogous with compile targets. Is analogous the right word to use for that? I kind of just pulled that out of thin air. Because ideally well, yes, the module here will have to have the identifier of this module so it can link to it at runtime. Programmer only needs to worry about these, and this is just magically found somehow. Which means trait lookup Yeah, trait lookup is going to be not module dependent. We're gonna have to do a pass over everything. And implementations are just going to be stored. Implementations will be stored in their modules, but there will be a lookup method. I'll have some lookup utility. That if you look on this type, you can find all its traits, and those traits can be defined in any module. They don't get shipped out anywhere though, so that doesn't really matter. And then from that point, once you have the trait, the type, and the trait on that type, the trait of that type, you can then find the implementations. So our path is going to look like module type generics. Do I want to make it explicit turbofish syntax, or do I want to keep it connected like this? And then trait, well actually this would have to be like trait path. So any trait generics are contained in there itself. Trait member. So that means that there's going to have to be a compiler pass. Where is add-in traits? Has to be somewhere in here. So we need to have an HIR pass that converts from type trait syntax to implementation ref syntax, or a syntax that is a direct reference to trait implementations to make sure that the trait is actually implemented. Um, let me check or ask if, like, is there a specific syntax Rust uses for implementing trait implementations? So you do for any type that implements it. Yeah, so that's like, you just import the trait name itself, but that doesn't import the so where the trait is implemented doesn't matter. Okay. Yeah, I'm not fully set on like which path I'm actually going to use. Or what path syntax. I don't like the type as trait syntax. It just seems very messy. Not that this is any cleaner. It is a very the trait as type syntax of like type path as trait path. This is a very, very clean way to make sure like generics, because generics would just be here. And generics would also be right here. And that just like, that's a good way to handle generics, because if you're just using straight turbo fish syntax, you might have a situation where it's generics and then immediately followed by generics, and you're not sure which generics are referencing which thing, because the type path could technically be, would probably be turbo fished as like, yeah. It's not aesthetically pleasing, but it makes sense. And then for the path itself, do I really have to do like search for a trait implementation? I guess I really do, because you do need both of those, and it's not clear which order which one should be in. sadness. So then this is the thing that we'll use to actually search for trait types or trait implementations. I feel like there has to be a fancy Rust way to handle commas. So if I map all of these into strings and then join, oh, what's the reduce? Self. So that's the accumulated version, and then this is the thing, accumulated plus. Yeah. There we go. This is a fun iterator way to make a comma-separated list. type as trait. And I think, yeah, that takes care of the majority of our HIR needs. So next step is to actually implement the parsing of all of this into HIR. Which it would be really fun to actually be able to print out HIR, so I might actually implement that as well. The ability to debug print HIR. Alright, I am going to be right back, and then we will go do that. Alright, I am back. Hopefully I can recenter this. Oh, it recenters itself. I can't wait to get my hands on a Beyond. It's gonna be amazing. I have to deal with a huge thing on my head. Thank you for the welcome back. Yeah, we're... Yeah? What? Okay, thank goodness. I just put it to sleep. Ugh. There we go. Whew. All right. Actually, I'm gonna... Yeah, maybe. We'll just have to deal with the slight uncomfortableness. Where were we going? Right, we are going to actually start parsing this out, which is going to be pretty fun. And we might end up implementing display for everything. Actually, labeled value ref. You know, we're going to start implementing, and then when we get across things like labeled value reference, that is large name. I want to rename that. Renaming that is easy. We're going to rename it now. Psych, we're not actually implementing stuff. We're going back to, name. Words. Words? Obsessing over things that don't matter. If we go to expression kind, somewhere in here there should be... Oh, wait a second. Wait a second. Idea. Since the way that I'm going to be handling this, possibly containing lifetime or type parameters, do they have an explicit so there's an unsafe, there's yield, repeat. Okay, so repeat is a inline slice. Yeah, it's like a slice constant. Struct is an inline struct definition, offset of, it's a macro, inline assembly, become. I don't know what that is. What is a become expression? Probably not what I want. Return, continue, break, address of. I will have to do an address of. There's our path. Indexing operation of field. I like field as a member access. Let's see, base expression. So where was field? There it is. Access of a named struct or tuple field. Oh, hey, Shadow. How goes it? Alright. So there's an assignment, block closure, match loop if. Let statement. I probably am gonna steal that. AST thing. Just lots of work? Yeah, same. Lots of work. I do need to actually make a cast. I just have constants and literals as the same thing. It's fine. Use statements. We're not doing use statements. Tuples. We already have. Anonymous structs. Method call array cast block. Alright, so my suspicion is correct. The way that the Rust compiler works is this is just a path expression. I've been really good. Did you see the news that Thrillfia and I won second place in the Space Jam? That's like the main bit of news of how I've been. It's a lot of work, still kind of recovering, but yeah, accomplishment. Yeah. I mean, it's good you didn't go check it out right away, because our bugs are fixed now. Most of them. It is a better experience now than when it won. But yeah, this is why I'm doing this refactor. Is because I can just, instead of labeled value reference, what we could do is just have a path block implement itself as what I'm doing right now is I'm rewriting my compiler so that when we go from document context, which I'm turning into a high-level intermediate representation instead of this document context thing. Targeting Rust HIR or just taking inspiration? Taking very, very heavy inspiration. Not like plagiarism inspiration, but like very, very strong inspiration. I like the way they name things and the way they generally structure things. And the language is essentially going to be Rust from Wish. So, yeah. But what I'm working on right now is making it so instead of the compiler initial like compiler pass being a right now the way it's structured is, if I can find it anywhere, let me see, this is, yeah, so I have this generate IR pass structure. And there's a ton of like recursive functions on here that go from our document context tree into the intermediate representation, which is yeah, what we're actually sending over the network. Like the final product is the intermediate representation. So I just have this generate IR pass that does that conversion. But there's instances where like you have kind of ambiguous, like you have a path to either like a local variable, a type, a function call, and that if it's a variable it could be used as a value or a memory address depending on what the operation wants. So I'm converting from just a giant function with a bunch of recursive calls, or a giant structure that's only purpose is to scope a bunch of recursive function calls, to instead I'm going to create traits and implement those traits on the upgraded version of document context, And then by calling those traits, it will essentially do the recursive function thing. But that means I could just have my version of path implement like a try variable, try function, try memory address, etc. And then pass in the context of the compiler and have that handle everything it needs to try to resolve what it is into what the caller wants, if that makes sense. As opposed to the caller always doing like, try deref, this potentially a memory value, potentially a register value, blah, 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 blah. I'm thinking right now, I can't fully explain it in an understandable manner, but it's potentially going to be a lot cleaner than what I have now. But I don't need a labeled value reference because I can just put path there, and then the code that using the path can call whatever trait implementation path has to try to get a value. Very hard to explain some things. Then what's member init? Member init is part of anonymous structure. When we're creating an anonymous struct. We'll keep that the way it is for now. Eventually, when we have non-anonymous struct definitions, then yeah. I guess I could just nest anonymous struct into like the way to do a non-anonymous struct. I said 3 intermediate representations just because that was easier to set it up that way internally. Yeah, I mean like Rust has 2. It has, yeah, I'm at the point where I'm looking at the Rust compiler for inspiration. Come on, give me the, where's my sidebar? Where's my sidebar of which thing this is? But yeah, so they have the AST, which of course they have their own parser. So their AST is something that they've generated themselves, and then there's the high level intermediate representation. There's the mid-level intermediate representation, and then I think there might just be IR as like its own thing somewhere. Be kind of funny if they did, but technically LLVM intermediate representation counts as another one. I'm gonna try to keep it just a 2 for now. And I'm right now parse like document context as it is kind of is a like secondary AST. So what I'm doing is I like just copy document context into this HAR function, and then I'm like trying to convert this to be lower level than just an AST so it's more useful. And then we're going to go straight from the TypeScript AST to high level intermediate representation. The optimization part of why it was 3? Yeah. Hopefully I can at some point write an LLVM front end / back end where I can just ahead of time convert my stuff to LLVM IR and then back to BraneScript IR so I can run LLVM optimization passes on it. And that way I don't have to write, like, upgrade stuff to SIMD operands and whatnot. So when I get SIMD support, or when I write SIMD support, I don't have to actually, like, make people write explicitly in SIMD or write SIMD upgrade optimization passes myself. Though it would be fun to, like, directly expose SIMD intrinsic functions, I do plan on doing that. So if people want to write their own SIMD stuff, because I might want to write my own SIMD stuff. What was I doing? Right. Something to do with deleting nodes I decide I don't need anymore. Oh, did I actually ever finish implementing these? I didn't I? Wait a second. I already have functions. Actually, it's fine. At this level, we can nest functions because of the way we want lookups to work. So we have functions and functions. Actually, it makes more sense to do members of the implementation and then implementation members and just like make it a clone of trait member, but with the actual implementation of things. I guess there's another question is, do I want to do this implicitly, like this, just so it looks cleaner? Kinda, yeah. Then I'm also gonna swap these. So this is a constant, this is the identifier, this is the type that we expect the constant to be. Or is it? No, there's the type. And then for the members of this, I do kind of like this enum pattern I picked up from the Rust documentation. It does mean that you can't iterate over a specific type unless you do like a filter, but it does mean for lookups it's more efficient because you just pull a lookup on one hash map and you're done. Also means you can't have name collisions by default. Why are there two anon structs? Oh right, because I was about to say, like, for regular struct, which is down here. I guess this is a struct def. I'm gonna change this to struct definition. And I'm just gonna call this struct member with the idea that, like, if there's nothing else there, it's saying that this is when this is the actual instance of the thing. And maybe instead of anonymous struct, we just do structure. And we optionally have the type of this structure. And if there is no type, and then let's also combine struct def and anonymous struct def. See, the thing is, function could be the actual implementation of the function. It's not. See, callsig is the definition of a function. And then body is the actual implementation. So I'm going to keep function as it is. It doesn't need to be a definition. Struct def identifier. We'll throw an option on identifier, and then we're done. Struct def now also works for anonymous structures. And here we have an implementation. So our passes are looking like we parent scope IDs when we do this conversion. We do an HIR pass to verify links. We also need to do a come on, where's my little, there it is. Need to do an HIR pass to convert from we need to change those references from generic. Basically need to resolve function paths. So I guess that is a question is how is the search for implementations going to work? Here we go. Okay. So instead of expression being an enum, I'm going to make it a trait. Oh, right. Where is Facecam? Oh, you're right. Where is Facecam? That's weird. Oh, I just had to reopen the window. Yeah, that was weird. Let me actually flip this. So I'm facing my code. Okay. Was it because it was minimized? Oh, it's because I minimized it. Okay, that makes sense. So I just need to keep it open in the background and not minimize it. That is a good thing to know. So, one thing that this expression enum is making me realize is that I did have problems before with like the expression versus non-expression nodes. And the way I was thinking about solving it was having expressions be a separate enum, and then having those be part of, like, there would be node, and then you would unwrap it, and you'd see an expression, and expression would be one of the node types in there. And it looks like the way the Rust compiler does it is exactly that same way. So that tells me that actually is a good pattern. So we should do a similar one. See, here's the thing, since oh, wait, I can still keep the box. This entire data structure is probably going to go through a refactor at some point, because you see, they are getting away with references here, so I don't know where they're actually making these nodes or storing them, because this tree is referencing things that aren't in a tree, if that makes sense. In fact, they might just be in a giant hash map, and then that node ID that they're all referencing. Because, like, if I go to this, there's this HIR ID. Which yeah, they might just be storing all these nodes in a giant hash map. It should be really funny. And then the actual tree data structure itself is not actually storing the data. Or maybe it's a giant vector? I don't know. Add all the nodes to a vector and then assemble the tree. Now I'm really interested. How are they storing? HR nodes. So where is node? So this graph. But where is node HIR referenced itself? I'm seeing so many similarities between this and like the direction my code is going. Maybe I should just fork the Rust compiler. Oh, that would be so cursed. Do you think this is something a chatbot would be knowledgeable on? In Rust, all the AST, HIR, and Well, the HIR nodes and enums store references to their data. Where is that data actually stored? Oh, I should probably say in the Rust compiler. Where is that data actually stored, and in what data structure? Might be like a green-red node sort of deal. Yeah, see, it knows that at least. Is arena allocated and stored in structures like arena T inside the Rust HER map data structure. The data is allocated once and referenced by lifetimes. How do you allocate all of it before? Is there like a single allocate, like, I don't know. So it's during the lowering from AST to HIR. You have this arena. And then they just call arena alloc. So it is the arena thing. Literal macro def use path owner info attribute. That's not a lot of HAR types to throw in there. Rust C arena, which defines a type-safe, compile-time verified arena allocator. So there's a typed arena. So I may have to look into this typed arena crate. Oh, what? You can't middle click on that? Wait, what? What? Here, 1 second. That is not a link. It's just a thing that when you highlight it, it looks like a link. Fake link. Yup. Dang, I'm gonna have to copy and paste it into a search engine. Screw you, thinking replacement. You didn't replace my thinking enough. They're very certain that it's but limited. Allocated objects are all destroyed at once. When the arena itself is destroyed, there's no deallocation of individual objects while the arena is still alive. Yup. I got. Oh, wait a second. So the way this works is it's a way for you to say when everything is destroyed, it's destroyed at the same time. So you're able to create graph structures using a generic lifetime, like one lifetime for all your objects. That is super useful, as long as you never need to delete anything. Which I guess, if you're doing passes over a... If you're doing repeated passes over a tree structure... Wait a second. That just means you can't... You don't... You not being able to deallocate things doesn't mean that you can't edit graph structures dependent on that data. And if you do need to add anything, you just allocate more, so it's like, it's a memory leak until you deallocate that data structure. Interesting. This is super useful. I'm gonna use this at some point. I don't know if I'm gonna use it right now. Yeah, I need to note that one down. Yeah, it's amazing what happens when you look at like first-party Rust code. It's like, this is a great example of how to use Rust. Who could have imagined that the people making Rust know how to use it? See, now I'm like, this is the problem with like referencing Rust source code. It's like I'm looking at all the stuff I'm doing, like, I need to refactor this. It's like, instead of like actually doing refactors to like the language, I'm doing refactor upon refactor to the same data structure. Well, I guess this is also the point at which I should, you know, refactor the data structure itself. You know what? Fine. We'll use the arena allocator. I got too curious and now I have to refactor the data structure itself. So instead of arc, this is now Wait a second. Can arena allocated things reference... Well, yeah, that's the entire point. Is things in the arena can reference other things in the arena. Yeah. Can I get... Oh wait, set... So you can only get mutable references to stuff. So if I do want to do passes, I'm either going to have to rebuild the data structure, so that means, yeah. That means once I construct this whole thing, it's going to be immutable. So I'm also going to have to invent a way to iterate over it. Actually, do these need to be references? Or can I just store the data in the enum itself? Since I might want to unpack this at some point, I guess it makes sense for it to be. Yeah. Oh, there we go. This is gonna take a while. Alright, and I wanted to turn this into a use statement. And then expression. Expression, I'm just gonna do expression. This is also going to be that. And we're gonna convert it to The variable definition is instead going to be use. Not use. I want this to be let. Okay. Const value. Ah, this does actually need a lifetime specifier. Actually, do I want node source to need a lifetime? That kind of is part of the node. Well, I do want the source string itself. So, yeah. Ooh, I can actually get a freebie on this one. Just a replace of expression with I mean, it wasn't found. There we go. So many lifetimes. What do you mean lifetime HR is never used? It's used, like, in all of the members of this. Like, you can have a node. Yeah, there's a node with a lifetime. Node source is in another node though, so we don't necessarily need that to be a reference. If you stream long enough, people will find you. The algorithm will eventually catch on. Yeah, not that you're really missing out on anything, because literally all I am doing right now is adding a lifetime to every single type in this data structure, because I made the mistake of looking at the Rust compiler source code, and I went, oh, that's an interesting pattern. Why are they doing that interesting pattern? Ah, I have to refactor all of my code now, because that makes too much sense. So, moral of the story is, don't look at references so you don't have to refactor your code. Man, I was like thinking in my mind, like, oh, what if I don't want every arena allocator to be on the same... Don't want all my memory in the same arena allocator so that I can... It's likely you would run into other issues later on, though. Yeah, I mean, I kind of already was, which is why I'm actually going through the effort of refactoring it. Actually, I don't need to make that a reference, since this enum itself already has references, so... Maybe that's the real reason for the vibe coding trend. They don't want to even look at their own code, much less someone else's. Real. Tech debt? I see no tech debt. Though, to be honest, vibe coding could probably make very quick work of what I'm doing right now. Just like paste it into ChatGPT. Hey, throw a reference on everything. Indiscriminately. But not check enough to get confidence it didn't make terrible hidden mistakes. Oh, I'm definitely making at least little hidden mistakes here. I'm expecting to have to fix some of these when I actually go to implement it. But yeah, usually whenever I actually use like AI for something, I'm like, hey, do this very one specific bulk operation, and I haven't had very many issues with that, most of the time. The problem is, the size of my code bases usually are significantly bigger than the context window of any model that I could get access to for free. Could I have a model get access to a model with a larger context window for not free? Maybe. But I can't test them. Oh, this is gonna make stuff so much faster. In terms of lifetimes. Multiple models trained on specific sections. But see, then I'm like, that's way too much effort. Then I'm like I'm training models on sections, multiple sections of my code base, specifically to help me out in those sections. But what if I have sections of my code base referencing other pieces of my code base? Like, what do I do then? It's just a whole mess. Honestly, what we need is a programmatic way to work with code. I mean, regular expressions in editors, like a find and replace, but with regular expression, kind of does that. Otherwise, like a lot of time could do a Python script to do something like that. A Brane implant would be pretty good too. Imagine if I could do Vim key bindings, but it's a Brane implant. That would be pretty sick. Something smarter that understands the AST. Yeah. Okay, why is this complaining? Do I need to, like, do that? No. By const value data, so I can in this const value down here pair all of those with the source data, because before I was putting source on every single variant of it, and I didn't think that wasn't very great to work with. So we're putting this here with node source there, and then data const value data here. Actually, I don't need a lifetime on that anymore. Variance with a single parameter is a warning. The compiler advises to use the name parameter instead. No. I'm not going to name every single enum variable. That sounds like an obvious troll. I'm going to be completely honest. Because I will point out that I'm looking at the compiler for Rust itself over here, and they are not following that format at all. In fact, they're doing like, in a lot of places here, they're packing multiple values into a single enum without naming them. So yeah, no, I'm not gonna do that. I mean, HR is never used. It's right there. My LSP might have just died. This dude on the field on the line before. Anyway. Yeah, it's always been confusing to me as well. I mean, on delete is sometimes useful because that saves a couple actions, but more often than not it is. it does get in the way. Oh, do I need to pass in an arena allocator to this? Get it to actually work? I think I do. Alright, so we now have typed arena. So back in here, I actually need to pass in an arena. Can this arena only accept one type? I believe the arena can only accept one type. So that means everything will have to be stored in a node. Alright, how long? Typed arena. See if it nope, it did find it. So we'll see how long this takes. Is this a compiled scripting language? Kind of. It's a just-in-time compiled scripting language. So, I mean, I guess that means we could fully ahead of time compile it, because I am using LLVM as the JIT compiler for the moment. Yes. So full compilation pipeline. Why isn't my LSP working? Did I write this? I'm just gonna restart the editor real fast. Because stuff is acting a little bit weird. It's arena for type. Okay, so it is an arena for a type. So we have to say for node. Then how do I specify the lifetime? HIR is the same as the lifetime of the arena. One question, do you ever watch other people work while you work? Like I'm writing a game system while I watch you write a game engine. That's the weird thing. I don't really watch scripting streams. I'm like either streaming or I'm just working with like music or whatever. So it's a very weird scenario where I'm not the target demographic for the content that I'm producing. I do watch coding videos though, like devlogs and whatnot. So this is, okay. So, cycle participant A. So we'll return a reference to the project, and we'll say, I guess I can just allocate it right here. Arena, alloc, project, and then does that work? Expected no. Oh. I guess I should implement some sort of like into node implementation. Expected project reference found project. Oh, because Right. Because the node data type stores references, and I can't have a reference until it's in the arena allocator. So what data type? What data type do I want to put in there? So what I need is an enum of every node type that isn't... Actually, let me check. Yeah, these are references. Then when I look at this one's arena, it's owner info, which I believe owner info is the contents of the HIR, owner nodes. Then it does parented node. Then it does node with a reference. as owner info. So it's a parented node. See, these are still references. So I'm just not sure where it's actually storing this data still. Note that all copy types can be allocated by default. They're not needed to be specified here. Oh. Well, then why do they specify literal? It's a copy type. Yeah, all of these are copy types. Dang, I was thinking that it was just gonna be like a generic, I guess, untyped arena. But no, it makes sense that it would be a typed thing. Well, here's untyped arena. Let's see, is untyped arena in here? What is single versus... Rust and Zig maybe handle every possible potential error fails in C, such as printf, end of file error that I'm sure 99.9% of people don't even mind to read about. All that just gave me sort of perfection complexity, making me code very precise, memory safe, and not prone to any errors fails. I don't think it made me go that far, but I definitely code a lot safer in just anywhere else. I'm very tempted to just use this untyped arena crate. Actually, does this have a source linked somewhere? No, not that I can see. Let's see this one. A dropping untyped arena. Sounds like what I want. How are we doing on issues? Nothing. How long ago was this updated? Only supports owned types for now. What do you mean by owned types? Does that mean like the type owns itself, it's not a reference? That's fine, that's what I want. This is something I need to do at some point. Make a interpreter for my intermediate language for debugging purposes. That will be fun. And super easy. Whenever I get around to it. Okay, I like this one. Untyped arena allocator. Here we go. But why does it have to be untyped? Because I want to be able to allocate any value of node in there. And no, I can't just allocate node because node stores references, not actual owned data. I want the arena allocator to be the owner for basically any type for anything in this file. And I could technically use a typed allocator, but to do that, I would have to create a giant enum and maintain that. I don't want to have to do that. See, a trait still requires an enum because it needs to be owned data, and I don't think I could just allocate like it would have to be a dynamic enum, right? It's not giving me errors, but it's not giving me, well, it's not giving me errors at all. Oh, version. I didn't update the version. See, is that really possible? Like, into a data structure, can you say, like, here, I have a vector of this trait, and it's not dynamic? That's the thing you can do? Because that doesn't sound to me like something very possible to do. Yeah, because that's essentially like, I would have to go arena and then the type to allocate here. So traits wouldn't work for that. Yeah, it would need to be only an enum. And I'm already having to do one enum, so unless I want to start writing proc macros to do multiple enums, yeah. Maybe good chance I'll refactor this to be something else later, like more type safe. But for something like this, the type safety of it doesn't really add or remove anything aside from possibly a tiny bit of performance. And at this point, performance isn't a problem. I'm not super familiar with how the sized trait works. All I know is that means it... yeah. New arena in the root. Oh, Rodeo is the name of their arena struct. Missing generics. What does it need? Alright, we'll see. I mean, with arena alligators, you're already kind of getting there. Yeah, traits are not types. When you write trait in a type position, it's usually a legacy shorthand syntax for dynamic trait. Dynamic trait is always unsized. Yeah. So unless the 6 years ago thing is out of date, which with Rust, I don't think it would be out of date. Yeah. Can't put trait in a type position. Which is, if I'm understanding correctly, is what you're suggesting to do. To avoid making an enum. What is the A? Oh, A is the allocator. Oh, that's why this is broken. I forgot a semicolon. There we go. Trait bounds are not satisfied. Arena Alec.